We continue with this MCQ by solving the number 14 and by starting from the number 14. Okay. Now in this given f of x equal to 1 over 2 plus sine x. Okay, so we have f of x equal to 1 over 2 plus sine x. The question is which of the following statement is correct? They say that this function has the same Maclaurin expansion of the function g of x equal to this. Let me just take this a bit more. Okay. So let's go to 11. It was 14, right? It's 14. This is 7. Okay. So the it has the same Maclaurin expansion of this function, but this function and this one, are they equal? No, there is nothing in common, right? So A doesn't make sense. You take two different how? Because I don't know why should them have the same Maclaurin expansion. Okay, the tangent line to the graph of f of x at the point 0, 1/2 has equation y equal to. We can find this tangent line and see. We also want to find the f of x is concave in x equals 0. You can find the second derivative and see if it is negative, yes or not. And f of x has an horizontal tangent point in x0. But excuse me, what is x0? We don't know. We don't even know what is x0. So this one here is meaningless. So we exclude E and A, right? Because what is x0? We don't know which point is x0. It's clear. So we remain with B, C, and D. But make sure that you can find this equation of the tangent. Okay. You can, if you want, you can compute the derivative and find the equation of the tangent. Okay, to find the equation of the tangent, you know that the point x0 will be 0, right? But it's according to you. If you think that finding the equation of the tangent will not take you time, you can check for the equation of the tangent. If the equation of the tangent is not the correct one, you have to check also if it is concave, if you don't want to do the Maclaurin expansion. Okay. But if you do the Maclaurin expansion, from the Maclaurin expansion, you can directly see if the equation of the tangent is correct or not. You remember or not? That it is possible to read the equation of the tangent from the Maclaurin expansion. You can read the equation of the tangent line at the point x equal to 0 from the Maclaurin expansion. So it's probably better to directly do the Maclaurin expansion and try to read for the other informations. Because if we do the Maclaurin expansion, we can directly see if the equation of the tangent is correct. If the Maclaurin expansion is not correct, we will directly check if the equation of the tangent is correct or not. So what are the steps? The steps are our step here, we try to be able to do the Maclaurin expansion of this function. Okay, to do we want the Maclaurin expansion of order what for this function? Of order, the question say the Maclaurin expansion of order 4, right? So let's start by doing the Maclaurin expansion of the sine. So we do sine of x, okay, maybe this is 2, sine of x is equal to x minus x cubed over 6 plus. If I go more, the next thing will be x to power 5, but I just need to power 4, so I will just write plus little of x power 4, right? Then the function will become f of x equal to 1 over 2 plus x minus x over 6, yes or not? Okay, I told you when solving the MCQ, I will not be, it's useless to be writing anytime the little o. So by the way, now this form here it look very close to the form 1 over 1 minus quantity, right? So I should try to flip it. I remind you that when I have 1 over 1 minus quantity, the trick is 1 plus quantity square dash 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 plus quantity to power n, right? So I try to flip, but it's look close, it's look like, but it's not exactly the form I need. So I should try to take out this 2 to transform this 2 into 1. That's why I rewrite the function f of x as a 1 over 2 multiplied by 1, okay, plus 1 over 2 multiplied by x minus x 3 over 6, right? Okay, thanks. Doubts? Excuse me. Okay, now it means that I can write f of x as this is 1 over 2, that is just this half, multiplied by 1 over 1 plus half of x minus x cubed over 6. But now we can easily see that this is just a number, so we don't care about it. We can easily see that we have 1 over 1 plus quantity, not 1 minus quantity. So we try to do a step more, saying f of x equal to 1 over, no, there is 1 half, then 1 over 1 minus, okay, it's minus, let's say minus, let's put the bracket, half of x to x minus x cubed over 6. Is that clear? Now what is my quantity? My quantity is all this, okay? So I mean that my quantity is all this, and we are doing the Maclaurin expansion, so x tends to 0. So if x tends to 0, then all this quantity tends to what? To 0. Yes or not? So as the quantity tends to 0, I can apply the trick, and thus f of x will become equal to 1 half, that was this half, multiplied by, I have 1 over 1 minus quantity, so it will be 1, then plus the quantity, that is minus half multiplied by x minus x to power 3 over 6, okay, plus, let me put it, the quantity square, that is minus half multiplied by x minus x to power 3 over 6 all square, plus the quantity cube minus half multiplied by x minus x to power 3 over 6 all cube, plus the quantity to power 4. Doubts? I stopped to order 4 because I needed the Maclaurin expansion of order 4. Okay, so now f of x equal to, so it will be there was a half that multiply all this half, right? So we will have the half, then we will have 1 plus, this will be half x minus x cubed over minus no, it will be plus x cubed over 12. Then next we have to do this square. Let me go and do it down. So it is minus half of x minus x cubed over 6. This is x cubed over 6. Yes or not? Multiply by minus half of x minus x cubed over 6, because this is the square, right? Minus half and minus half give 1 over 4. Then you have x times x, which is x squared. X times x cubed over 6, it gives you minus x4 over 6. Minus x cubed over 6 multiply by x gives you minus x4 over 6 again. But this minus x cubed over 6 times x cubed over 6 is useless, because it will exceed order 4, right? So it will just give me 1 over 4 multiply by x squared minus x over 3, x4 over 3, right? So I go up and I write that it is 1 over 4 x squared, so give us plus 1 over 4 x squared and minus 1 over 12 x cubed. No, x4. Doubts? Okay, excuse me. What is can you repeat your question, please, so that I can repeat? Okay, so the question of my student is that how did I get 1 over 12 x4 here? In fact, here I have 1 over 4 out, right? This is minus x to power 4 over 6 minus x to power 4 over 6. That gives us minus x to power 4 over 3. When I expand this 1 over 4 times x squared, it gives 1 over 4 x squared. 1 over 4 times x4 over 3, it gives minus. Okay, so now I remind you that this here is this, yes or not? So now we need to do this. So we need to do this stuff cube, right? So so what we need to do is to do minus half multiplied by x minus x cubed over 6 all cube, but the stuff cube is the stuff square multiply by just the same thing. Yes or not? But we already know this. We know that this is 1 over 4 multiplied by x squared minus x4 over 3, right? So you just multiply by minus half, is minus half. Let me cancel. This is minus half multiplied by x minus x cubed over 6. When you want the number will be minus 1 over 8, right? Then the quantity will be x squared times x is x cubed. X squared times x to power 3 is useless, because it will be x to power 5, but we are expanding for order 4. Then minus x to power 4 multiplied by anything, you take any, it will be useless, right? So we just keep this. So this is just minus 1 over 8 x cubed. Okay, we go back, we go up, and we write it. So it will be, this here gave us just minus this one here, okay, this gave us only minus 1 over 8 x cubed. This is 8. Okay, then the final is this stuff to power 4. The stuff to power 4, so minus half multiplied by x minus x cubed over 6 all to power 4 is the 1 over 3, or is the 1 to power 3 multiplied just by minus half multiplied by x minus x cubed over only once. Yes or not? But we already saw that this was minus. Yes or not? So we just multiply by minus half of x minus x3 over 6 just to power what? Yes, nothing. There is no power. Yes, so we will just do this multiply by by multiplying the number we get 1 over 16. Then we have x cubed multiplied by x, which is x to power 4, and that's all, right? So we get plus 1 over 16 x to power 4. Then we can easily we can cancel some of this stuff to have some space. Okay. Turning back, we conclude that the expansion of f of x is just 1/2 that was out multiplied by, we have this one, we don't have any other one, then plus we have half x, there is no more x, the x square, we have plus 1 over 4 x squared, and that's all, right? Then for x cubed, this is x cubed over 12, this is x cubed over 8. This x cubed over 8, let me use x cubed over 8 is like x squared over 12 is like doing 2x squared over 24, right? Okay, but this is minus 3x squared over 24. 3x cubed, is cube. Doubts? Okay, so this is 2x cubed over 24, and this is minus 3x cubed over 24. So we will just remain with minus x cubed over 24, right? Then finally we do the for x4. X4 we have x4, here we had x minus x4 over 12, so here we have minus x4 over 12, that is like 4 minus 4x4 over 48, right? And this x4 over 14 is 3x4 over 48. Okay, so when you make it, you will remain with minus x4 over 48. Okay, so here, okay, just wait. Here is the formula here is the final formula that we get. So we get that the Maclaurin, I know it took some time, for probably it was better to do the tangent and the stuff, but I like this because it helps you to, it gives you an idea about how to apply the stuff in order to get the Maclaurin expansion stuff. Okay, if we go, let's go and compare it. For example, from this we saw that the equation of the tangent line is y equal just to half plus 1 over 4x. Yes or not? Because we stop doubts. Okay, so we're going back on the PDF with what? No, for the tangent line, the equation of the tangent line, we stop when you are reading the equation of the tangent line, you stop at order 1. No, but there is half out. There is this half out. So what is the right answer is then this one. Yes or not? It's exactly what we got. Okay, so the answer is C. 14C. Okay, doubts? Okay. Let's also solve the 15 one. The quiz 15 just says that let me clean the board before. Okay, so we have the function, the principal part of the function f of x equal to exponential of 1 minus cosine x multiplied by, so we have f of x, let me change the color, I don't like to write with the, so we have f of x equal to exponential of 1 minus cos of x minus x sine 2x minus x sine 2x minus 1, and we want the principal part of this function for x tending to 0. I told you a few minutes ago that the principal part is the most important term of the Maclaurin expansion, right? But here you see that there is a principal part with x to the power 4, another principal part with x to the power 2, something x to the power 2. This cannot be a, so D cannot be a principal part. The principal part is a single term, right? Single monom. So it is not, this is, D is false, and also E is false. The principal part is not an expansion. Okay. So the answer is between A, B, and C. As the answer is between A, B, and C, we see that this is of degree 4, this is in degree 2, and so what we understand, it means that if I do the Maclaurin expansion of order 2, and if one of these two is correct, I should already be able to see it. Yes or not? I don't need to do the expansion until order 4, because if I do only the expansion until order 2, if one of these two is correct, I am able to see it. So that's why I just do the expansion until order 2. Okay, if I want to do the expansion until order 2, I start by the cosine of x, right, which is 1 minus x squared over 2. Then I do this, the exponential of 1 minus cosine x, that will be exponential of 1 minus x squared over 2, right, equal to exponential of x squared over 2. Now in fact I have exponential of quantity, and the quantity is tending to 0, because I remind you we are doing the principal part for x tending to 0. So the quantity is x squared over 2, and it is tending to 0. So we conclude that this is equal to 1 plus the quantity, because I remind you the trick of the exponential is 1 plus quantity squared over 2 and dash dash dash. So here the quantity is x squared over 2, it will be 1 plus x squared over 2. But if I do the quantity square, I will be getting x to the power 4, but I don't need it because I say I want to stop at order 2, right? So this is plus literal of x squared. So we reach that exponential of 1 minus cosine x is just 1 plus x squared over 2. Now we still remain to with the sign of 2x, right? Look that we don't need to do anything on x because x is already a polynomial. Remember, the goal of the Maclaurin expansion or Taylor expansion is to approximate the function with the polynomial. Okay, so we go on sine of 2x. Excuse me, let me write it better. Sine of 2x is sine of quantity, and the quantity is tending to 0. So it will be the quantity 2x. Then I am supposed to write minus the quantity cube. But if I do 2x cube, it is going to be greater than x squared. So this will just be 2x plus little o of x squared. Okay? So the function now f of x can be written like the exponential part, exponential of 1 minus cosine x, that we saw it to be 1 plus x squared, right? So it will be the exponential part that was 1 plus x squared over 2. Then there is minus x multiplied by the sign, so minus x. The sign was just 2x, right? Then finally plus 1. No, minus 1. Doubts? So we get f of x equal to 1 and 1 cancel. We get x squared over 2 minus 2x. Minus 2x squared. That gives you minus 3 over 2 x squared, right? So f of x is equal to minus 3 plus little o of x squared. But we don't need the expansion, but we need the principal. So the principal part. So the principal f of x is equivalent to minus 3 over 2 x squared. Pay attention that usually students do all the stuff like they reach this place, and at the exam, instead of taking the right one, they take the one with the little o. The principal part is not the expansion. The principal part is like the most important term of the expansion. Is that clear? So the answer here is B. 15B. Can you repeat your question, please? Yes. Because no, before I skip it, because I told you I don't like to keep writing little of x squared. You mean here? I told sometime I write it, sometime I do not. I am supposed to write him every time, but I don't like to keep it, or to keep, and I advise you to not keep writing it every time when solving an MCQ, because it's not important. Only at the end I write it to refresh that I was doing an expansion. The degree, because the next term coming after 2x was what? Was 2x. Okay, I repeat the question of my student. The question is, why here we have little o of x2, not little o of x? The problem is that after this 2x, if I am doing the sign, it was 2x, the quantity, then minus the quantity cube over 6, right? So this quantity cube over 6 is directly, it's little o of x squared, because it comes with the cube. Even if you write little o of x, it's not wrong, but you are doing the Maclaurin expansion of order 2. We decided to do of order 2. Tell me. Yes. Also because when you here we did an expansion of order 2, we stop all the function at order 2. So when you expand, stopping all the function at order 2, you expect to reach something with little o of x squared. Okay, and this also concludes this recording section, and we will solve the next MCQs in the next in another section. Okay.